Alright, so here we have another look at our datapath. We have already seen the details of the ALU and shifter, which are two of the main components that we have in the datapath. And now here we have another look at our datapath without having too much details regarding ALU and shifter and also the registers that we had. So the registers and the multiplexers together with the decoder and enable hardware for accessing them now become a register file. So we already have seen how the register file works indeed. We know that we can provide two addresses to get data out from the register file. An address, data address, in order to write new data into the register file, and also we have the write command input. So out of it we can take the two lines of data, A data and B data, each line with a number of the elements. So this indeed replaces the set of the, let me go back to show you just how our datapath looked like initially. So the register file replaces the whole area that you see here. Okay, so the whole thing here, including the registers, multiplexers, and decoder, is replaced with the register file. And then for the ALU plus shifter, now we show it as a function unit. So this function unit contains ALU plus shifter, and if you remember, we also had the multiplexer in order to choose among these two, and we have some combinational circuit for generating the status bits. The status bits are here, V, C, and Z, which are generated indeed using a part of the combinational logic circuit. So now we are representing the ALU, shifter, mux F, and the status hardware as a function unit. So this function unit includes all those. Apart from them, we still have the mux B here, which we had in the initial datapath representation that we had, and we also have the mux D, which is used in order to pass new data from outside into our datapath. And mux B is used in order to pass some constant input whenever needed. You can again compare what we have here with the initial, let's say, datapath. Now the multiplexer select inputs that we had for the registers, now they are A address and B address. So A address and B address, originally we had them in the form of multiplexer select inputs. We had a decoder together with our registers. Now it is in the form of D address over here. Multiplexer outputs become A data and B data. So these are now A data and B data. In the previous representation, they were the outputs of the multiplexers that we had for the registers. And input data to the registers now becomes the D data. And we also had the load enabled to our registers. Now it is the write command. The register file now appears like a memory. You can look at it, yeah? So over here, it is similar to a memory. We can provide the address to read the data. We can provide the address and the data in order to write the data into the memory. So the register file looks like similar to the memory, which is based on clocked flip-flops, but here we don't, the clock is not shown for the sake of simplicity. And a function unit that we have here, which is composed of mainly the ALU plus the shifter and the other components, is quite straightforward. We know the internal structure and also the status bits that they have, that we get out of it, the data F that we take from the function unit, and the input A and B. But FS right now is not clear. Yeah, what is FS? In the previous case, we, instead of FS, we had G select for the ALU part and H for the shifter. So this was for shifter and this G was for ALU in order to determine what operation to perform within the ALU. And we also had MF select in order to choose among these two, whether to have ALU operating or the shifter operating. Now the FS, the function select init, function unit select codes are defined in this way. We are going to use 4 bits for it, starting from 0, 0, 0, 0, going up to 1, 1, 1, 1. We have this set of micro operations to be performed. And for each code, we have a corresponding code for MF, for G, and for H. Obviously, for the ALU operations, the values that we have for H will be don't care, and on the other hand, for the shifting operations, the values that we have for G select will be don't cares. And then for MF select, it is kind of obvious. When MF select is 0, we will have the arithmetic and logic operations. When MF select is 1, we will have the shifting operations. So then the codes are also determined for transferring of A to the output or incrementing it, doing addition, performing subtraction, and all the operations are determined. And then we kind of have the truth table. The input side will be FS, and on the output we can find the expression for MF select for the bits of G and for the bits of H, and then we can implement in it the combinational logic circuit which is required in order to obtain MF, G, and H signals out of the function select. And therefore, by providing the proper code to function select, a proper desired micro operation will be performed.